can make a start. Hopefully you can all see my screen. So today our focus is looking at how to support children with maths at home. Now, unfortunately, what I wanted to do was spend the first hour doing the theory side of things, and then the last half hour getting your children in, doing some practical activities like we did for the reading session. But because of the rise in school illness with both staff and children, we felt that that wasn't particularly beneficial at this particular time. So hopefully we can do it in the future. I will be sharing practical activities throughout, and also giving kind of links and ideas to resources that we use that you may want to use at home as well. Tomorrow I will be sending out all the resources for the reading, writing and maths sessions that we have done, so that they're all together in one email for all the parents, including yourselves as well. So everything will be in there. So to make a start, the aims of the session is to share the best practice that we have at Groveland's, to look at the 3 stages of the maths curriculum, because each school is very different in terms of how they approach maths. And I want to share the Groveland's maths curriculum with you and the calculations policy. Also having a look at the White Rose materials, which is a programme that we follow at Groveland's as well, and you may have seen during the first and second lockdown. To share strategies to support children with SEND, EAL or pastoral needs with maths at home. So for those of you who don't know me, I am the assistant head teacher for inclusion. So not only are we going to be talking about the calculation policy in general today, but at the end of the session we'll be talking specifically about supporting children who may have additional needs, EAL or pastoral needs, so support with mental health and well-being. I also would love for you to kind of stop at any point and to share your own family context and discuss the amazing things that you're doing at home, and also to ask any questions during the session as well. So there is a lot of content, I will warn you, in today's session. We will be talking about all of the 4 operations, so addition, subtraction, multiplication and division, and the 3 stages within the maths curriculum. So there is a lot of content, but please do stop me if you have any questions or want to make any comments as well. So the first thing which is super important for me to know is, what would you like to get at from today's session? So obviously the session is how to support children with maths at home. So if you could just put in the chat, or you can shout out, that's absolutely fine, about what you would like to get from today's session. That will really help me to make sure that I have met your kind of objectives for today's session. So I'll just give you a minute to kind of write in the chat what you would like to get from today's session. Absolutely, Claire, we definitely will talk about that, to how to make it more fun, how to make it more practical, and that will be discussed within the 3 areas and stages of maths as well. So thank you for your comment. Okay. Recording in progress. Oh, sorry, I didn't hear that. Oh. Okay, so we'll carry on. So in terms of the national curriculum, we have 3 stages within that, and we follow that very closely at Grosvenor, and so does the White Rose programme that we follow as well. So the 3 progressive stages starts with the first one, which is fluency, which is just as it says in the name. So just becoming fluent within that particular area of mathematical work. So at the very beginning of a unit of work, children will use lots of kind of concrete apparatus, visual representations as well, to make sure that they're really getting an understanding of what they're learning about within that particular unit, and that is really, really important for us. So if you kind of walk around the school at any point during the day during a math session, you will see that there's lots of concrete apparatus out, lots of visuals out to support our learners, and that's not just children that have got additional needs, that's all of our learners. That is the first stage. So having things like number lines that you can see on the right there, having compare bears, which are little coloured bears that they can count, which I'll show you a little bit later, having unifix cubes that they can put together, having beads. So there's lots of different things that we have, Numicon as well, to support them with understanding maths. And that's really important because we want them to have an understanding of maths in the literal form, so they can see it literally before they get to that abstract concept with problem solving and reasoning. So like I put there, the aim is for children to become fluent in the fundamentals of maths with varied and frequent practice. So we make sure that they're really, their skills are really embedded in this area before we move on to stage 2. And at home, you can do exactly the same thing. You can do it with whatever you've got at home. You might have cubes, you might have things. In the early years, we do it with lots of different things like pasta shells, and with, you know, even crayons, whatever you've got at home that you can count, which you will have objects at home. As long as they're the same object, not to confuse the child at the very beginning, then counting can be done in lots of different ways. We also use the outdoors to do that as well, so using chalk on the floor to support with that as well. But there'll be lots of practical ideas as we go across along the session. The next stage is problem solving. So once they've become fluent in that area of maths, we then look at solving problems together, which is moving away from that visual representation to the abstract. That is not to say that when they are problem solving, like you can see the questions on the right there, that they can't use the concrete apparatus or visual apparatus. We always have that alongside the children as well to support them if and when they need it. So again, the children are applying their fluency skills to answer problems, and they can do that in lots of different ways. So as you can see there, it says Liam has some balloons, he has 7 red balloons, he has 2 more green balloons and red balloons, he has 3 less blue balloons and green balloons. And in this particular maths question, we would get the children to draw that out. We would use visuals, we might use unifix cubes as well to represent the balloons, so have the red, the green and the blue unifix cubes to represent that particular question as well. So if your child is doing any problem solving and reasoning at home, please do not think that they just need to answer the question off the top of their head. They can use the concrete and visual representations to support them with that answer, and the more they do that, the more they're going to be confident in the future to not use those materials and to be able to do it more fluently without the apparatus as well. So yeah, the apparatus is definitely there to help them. So that's stage 2, problem solving. And the last stage of the national curriculum and the White Rose programme is reasoning. So once they're fluent in that area of maths, once they can solve problems, they're then going to justify and use evidence and use their fluency skills to answer those reasoning questions. And this can be in the form of true or false. It could be that they have to agree or disagree with a statement. And what we say to the children is, we don't just read a question and say, yes, it's true or false. We don't just read a question and say, yes, we agree or disagree. We use our maths knowledge to say, why is it true? Give me an example. Why is it false? Give me an example. And again, even though we've moved away now to the very abstract element of maths, which is just the question there, you can see that there are visual representations within that as well. So there's already those kind of counters within that question. And again, they can use that concrete and visual representation to help them with that answer. But we do expect them to use evidence to support their answer as well. And we use that kind of phrase, can you prove it? We give them sentence starters like the one that I've put in blue there. I agree, disagree with, because. So if you could do the same at home as well, like how do you know? Prove it to me. That will help them, and it mirrors the same language that we use at school as well. And I've got at the bottom there that you may hear the term mastery being used with regards to maths. It's very much a very kind of recent maths term, especially in the last 4 or 5 years. And what we mean by that is that the child has mastered all 3 of those stages. So they have gone from being fluent to now being able to reason with that within that particular area of maths. If we find a child is finding reasoning quite tricky, we then give them, like I said, lots of scaffold and support to support them with that, and asking them to use what they know from the very beginning to support with their answers. That might be that they work in pairs to do that, so someone else is modelling it to them, or it might be that they're using lots of different apparatus, or it might be that they use that they watch that we address their misconceptions by relearning and reteaching them again in that particular area. So there's lots of different ways that we would support the children if they're finding reasoning quite tricky. This is just a quote from the national curriculum which talks about maths as a subject. So I'm not going to read it, I'll just give you 30 seconds to just have a read. While you're doing that, I'm just going to have a look in the chat because I've got 5 comments. Thank you everyone for your comments. So this does go all the way. It talks about, this particular session is talking about the 3 stages which we've just quickly summarised, and it does talk about the kind of levels within the 4 operations, and I will give you some kind of examples of what that looks like. After today's session, what I will then give you is the Groveland's calculation policy, which shows all of those 4 operations and the progression of that from year 1 all the way up to year 6. And that will make it really clear to show what addition strategies you use from year 1 and how that progressively builds up to year 6 as well. So today will just be about those 4 operations and some examples and practical examples of how to support children with that. But the document will break that down further into the year group. So that will be sent within the email. And also, absolutely, we do want to keep children's kind of pleasure. You know, we talk about reading for pleasure, we want the same for every single subject. So we want them to be enthused by maths, and we say from the early years to do that in lots of different ways, lots of practical ways, using the outdoors, like we said about the chalk, and lots of other ways as well, using nature. I'm going to talk a little bit about that at the end of the session. So moving on. So in terms of mathematical skills, please don't be alarmed, it looks quite frightening, this image, but it's just saying that, like the national curriculum had stated, that all these arrows connected here, it's an interconnected subject where everything is very much linked together. So we're using skills from lots of different areas all the time when we're talking about our maths. And what we want to do is we start with our active and concrete in the fluency stage and move to the abstract when we're in the reasoning stage. But as you can see from the arrows here, it doesn't mean that we're always just going to be in the abstract stage with the reasoning. We can go back to the active and concrete, like I said, to help support that reasoning stage as well. For some children who find abstract learning quite difficult, especially those who may be on the ASD spectrum. We obviously want to make sure that we're always using those active, concrete and multi-sensory approaches to learning to support them with those abstract concepts. So as you can see, the arrows are always moving up and down. We don't just say, here's a question, you can't use anything to answer that. We make sure that they've got that those concrete and visual representations to support them. And we ask children to show their working out as well. So either around the question, or they have some jot paper next to them to help do all their working out, which is then attached to their work, so we can see their processes as well. And when they go into year 6, so I used to teach in lots of different years, but I was a year 6 teacher for 7 years. And when the children get to year 7, a lot of the reasoning will be, can you prove it? Can you show you're working out? And the answer, the mark scheme is usually 2-3 marks. They get the full marks if they show they're working out and have the right answer. However, if their working out was on the right track, but they've got their answer wrong, they still get marks for showing they're working out and showing that they were on the right kind of train, using the right train of thought. So that's why we always say to the children, please show your working out, so that we can see what led them to the answer, because they will get marks for that when they come up to year 6 SATs. And it's not just about SATs. We're not a school that is about SATs. We want them to show that because we want them to understand and master the skill from the active concrete all the way to the abstract as well. So we talked about concrete resources. So you may have some of these at home, but like I said, please do not worry. Please do not spend lots of money trying to get these either, because you can use lots of different things. I use pasta shells with my 4-year-old at home. So please use lots of different things that you may have at home as well. So these are the things that we use at school. So we have a count stick that we use, and we use that in lots of different ways. If we're counting on consecutively, or if we're counting on using our times table knowledge. We also have bead strings. We have place value counters as well, which are used in lots of different ways. We have multi-link. They can be called unifix cubes as well. We have Cuisenaire as well. We have lots of number grids, lots of number lines, and Numicon as well. And we use all this apparatus with the children. I think, Tanya, you asked the question about different methods. So what happens is, from nursery, we teach children all the different methods following our Groveland's calculations policy, which you will see in the calculations policy, how it progresses through the years. But when they get to the end, so when they have kind of completed their curriculum and they're demonstrating their knowledge at the end of year 6, and even year 5, and even before that, they can use whatever method they are comfortable with. So what the method that we use, which I haven't put on here, which I will put in the resources, when we're answering more of those abstract concepts, is called the Rucksack Method. And Rucksack stands for read, underline, so underline the important information, choose your operation, select the method, answer, and then check. And I will put that in the resources as well. So by the end of year 6, every child should know, when they followed the curriculum, all the different methods that they can use. But children have their own preferred methods, and we encourage that. So we say to them, what is the best method for this question? What is the easiest method and most efficient method that you can use? So we put it on the children as well to be independent in their learning and to choose that. So we're now going to talk about the 4 operations, so addition, subtraction, multiplication, and divide. And as you can see on the right there, I've just put the keywords kind of mapped, because as the children kind of learn about those operations, we also talk about the different words that are used to talk about those operations as well. So addition can be known as add, or sum, or plus, or increase, or total, or together. And that's really important, because when they get to the more reasoning questions, there may be a language in there which indicates what operation is being used. And they may not explicitly say, can you add these together? So they may say, what is the total of these two amounts? And the children will have to understand that total means, oh, okay, it means add them together. So using that language at home as well is really, really important. So what words do you know for subtract? What other words do you know for multiply and divide? And that is super important. And again, I will attach a keywords poster to the resources at the end as well, so that you can talk about that with the children. Language plays a really heavy part in maths, especially when you get to the problem solving and reasoning. So children's understanding of these words is super important. For some of your children, I will speak about this at the end as well. Those that find language quite difficult, so cognitive vocabulary, what we do is something called pre-teaching, where the learning for the next week is taught to the children the Friday before. So they look at those keywords so that when they come to the new learning next week, the following week, it's not too overwhelming for them because they've already been exposed to that language. They already know what that language means as well. And also to find out what your child is doing in maths the next week, the following week, in the newsletter, thank you to Tanya, we put down what the children have learnt this week and what they're learning the following week in those core subjects and also the foundation subjects as well. So please do read that, especially if your child finds maths quite overwhelming and needs that kind of pre-teaching to support them as well. And also so that you can look at what's happened this week and see if they've been able to master those skills. And I'll share some resources with you on how you can do that as well. So back to this. So the operations, we have 4 operations at the very beginning. As the children get older, they will be introduced to something called orders of operation. And sometimes this is known as BODMAS or BIDMAS, as you can see at the bottom there. So when they get into year 5 and 6, there will be more operations in the form of orders and also brackets as well. And BODMAS and BIDMAS clearly shows you what order they need to put things in when they have a mathematical sentence. And again, that will be in the policy to explain that a little bit further as well. So we're going to start with addition. So the structures of addition is as follows. So we follow the work of Haylock and Cockburn, and they worked closely with the National Curriculum for Maths to support with thinking about the structures within it. So with addition, from the very beginning, children will learn about the total of objects together. So if I've got this amount of objects and then I add this amount of objects, the total is this. They also learn about augmentation, which is the next step, which is you start at a number, you count on, and then it increases by how many, and the total is. And then the last thing that they learn is the commutative law, which is knowing that if I say 4 plus 3, it's the same as 3 plus 4. Okay, and they know that within multiplication as well, and they're taught that subtraction and division doesn't follow that same pattern. So that's what we're going to start with today, is looking at that. So aggregation, as you can see here, if we were at the fluency stage of aggregation, we would have lots of visual and concrete apparatus and representations to support us with this. So as you can see, there's 3 blue counters and there's 4 red counters. So we would ask the children to add these together. Now they can use their fingers to do this. Please don't discourage children to use their fingers. Please don't discourage them to put their finger on each of the objects either, because this really helps them to understand one-to-one correspondence and also the value of objects as well. So if your child is still having to do that even in the later years, please encourage them to do that, but please do flag that up as well so that we can give them the extra support in class. So the second model that you can see, this is called a part-whole model. And the reason obviously is because the parts make the whole. And you have the 2 circles, they're the parts, and then they're leading to the total, which is the whole there. So we would read that to children as 3 plus 4 is 7. And we can put the symbol in there to help them if they need to. But usually when we're showing them a part-whole model, we show them the part-whole model in this way, and it can be presented in lots of different ways. So for home learning, you may see that it's represented at a diagonal and lots of different ways. So it's really important to say to the children and to encourage them to look really carefully at the part whole model to see where are the lines leading to, because that will be the whole. And I know that sounds really obvious, but that is something that children find really, really difficult, especially when it's put at an angle. So that's really important to kind of just unpick with them. And then the last model that we've got at the bottom, this is called a bar model, so B-A-R. And again, it's put as a bar, and we can see the top one is the total, and then underneath we've got the parts. And in this one, it's really important because we're also demonstrating to children the amount that we're working with as well. And we demonstrate that really clear in the bar whole model. So we don't just put an equal line between the 3 and the 4. You can see that the 3 is smaller than the 4 in the bar model. And when the children are doing the bar models at home, please encourage them to think about that. Look at the numbers in the parts. How would they be represented in the bar model? And obviously it is just an approximate amount. We don't need to kind of get our ruler out or anything like that, but we can clearly see that 3 is smaller than 4 in here. So it's kind of their understanding of the value of numbers as well. So these techniques and strategies are really important to use with our children in the first stage, so the aggregation. But like I said before, and like we had in the quote by the National Curriculum, everything is interconnected. So even when they're doing reasoning, they can draw any of these representations to help them solve that answer, and the same with problem solving as well. So please don't think it's just for the fluency part. Please do use it for the problem solving and for the reasoning as well. So I am going to give you a little bit of practical work to do now so that you can understand how to do it with your children. So on a piece of paper, I should have said that at the beginning, or on your phone, can you use the information that is on the screen to create the part whole model and a bar model? So think about your total, think about your parts. And when you're doing your bar model, think about how you're going to represent the 4 and the 5. Have you shown that 4 is smaller than 5 in terms of value? And you don't need to show me, it's just for you to have a little play. Perfect. So hopefully you would have had something like this. So your part whole model, you could have done in lots of different ways. Okay, so we know that the total, we know, sorry, I didn't know which order I'd put it in. So we know we've got 4, so we're going to put that in our part. We know we've got 5, so we've got 4 open umbrellas plus 5 closed umbrellas, and then we're going to count that together, so we can use lots of different things. Your children can to add those together. They can use a number line, or they can count individually using counters or Unifix cubes or Cuisenaires, absolutely up to you. And then they would work out that the answer is 9. And then with the part whole model, 4 plus the 5 is 9. Again, your total is on top, and as you can see there, I've made sure that my 4 is represented as smaller than the 5, and hopefully you got something along those lines when you were doing it. Again, I'd like you to have a little go at this. So it says, can you use the information below to complete the part whole model and the bar model? So have a look at the information with the red hats compared to the blue hats. And then I would like you to fill in the missing information in the part whole model and in the bar model. Again, have a look at the bar model and how the 2 is represented compared to the 8. And also look at the part whole model, like I said before, about how sometimes it's put at angles. And that is just to make sure that the children understand that which are the parts and which is the whole. So hopefully in the second one, in the part whole model, we know that even though that's at an angle, the 2 and the 8 are leading to one number, which is the total. So 2 and 8 are the parts, so we add those together. So 2 plus 8 is 10. So I would write that in the the part whole model. And then the bar model at the bottom, we know that the total is at the top. So therefore, we're going to add the parts together. So 2 plus 8. And again, we can use lots of different apparatus to help us with this, is again 10. So you can see that it's presented in lots of different ways. It's presented as visually with the hats, it's presented in the part whole model and also the bar model. And you can do the same at home as well. Children can draw circles. We get them to draw circles to help when they're representing something that they need support with. So the second stage, once we've done the aggregation, which is just counting, is the augmentation, which is counting on. And this is with the support of number lines, which will help them. But we also have this really lovely practical and visual representation called the first, then, and now. And we use this with the children to really help them with understanding the process of augmentation. So first, we have 4 children on the bus. Then 3 children get on. Now we have got 7 children. So we would say to the children, once they've seen this image, so they would only see the picture form at the top, is can we now put this into a mathematical number sentence? So they would look at the first, okay, let me write 4 down. They would look at the then, okay, there's 3 children that want to get on, so plus 3. And then they would look at the now. Now, when they're working this out, they will use a number line to find 4. They circle the 4. And then they make the 3 jumps, and we get them to physically do this on the number line. So 1, 2, 3, where have you landed? It's 7, let's circle it. And we always go through that same process with them. And they always circle the first number and then make their physical jumps and do the last number. And again, make it really practical. At school, we would get children up and do it with children. And I know that you might not have 7 children in your house, but make it as practical as possible. If you've got action figures, dolls at home, do it with them. Also, your number line, we do it very practical, very kinesthetic. So masking tape on the floor, having the numbers there, the children physically making those jumps. The same with chalk. You can do chalk on your patio or wherever you live. And again, they can physically draw the jumps on there. So please make it as fun and as practical as possible, because the children really like that kinesthetic approach. And also think about how your child learns best. If there's a lot of auditory, so a lot of speaking, which apologies, I know today is a lot of speaking, and that's tricky for them, then what is their best way of learning? If it's kinesthetic and getting up and moving, then make their learning like that as well. Use action figures, use chalk, get them to physically do the jumps themselves. And again, if they're visual, get them to draw it out. So just think about your child and how they learn best. So I will, in today's tomorrow when I send out all the resources, we'll also be putting this in the pack as well, which is a first, then and now grid. And it is so important to use with your children, especially at the counting stage, whether you're counting forwards or counting backwards. So how many did you have first? So they will draw the picture in there. Then how many did you have? They draw the picture in there. Now how many do they have? They draw the picture in there. Once the picture's there, and those pictures may already be there, they may be pictures that they've got in their home learning or that you've put there, like I showed you with the bus, you then say to them, okay, how can I write that down as a number sentence? So they write that down as a number sentence, and then they use any form to work that answer out. If they're finding the number line really tricky and they can't quite get their head around it, go back a step to the aggregation stage and get them to physically count beads, pasta shells, Unifix cubes, whatever you've got, and do it individually that way. So please take them a step back if the number line is a bit too tricky for them. This stage also leads really nicely to the next stage of the addition process, which is the commutative law, where children understand that they can write addition number sentences in two ways. So 4 + 3 is 7, which means 3 + 4 is 7. So it helps with that as well. And you can talk about that as well. So if you've got two children at home and they're doing it, did you write it a different way? Oh, that's interesting, because that shows that it's the commutative law. So always having those conversations as well. And you can obviously engineer it in that way as well if you're doing it with your child. So just like I said before, number lines are really effective to count on. That's what we use at school. But again, please use beads, unifix, cubes, compare bears, which are these bears here, these coloured bears that you may remember, abacus, whatever helps support your child with counting on. I haven't shown it here, but like I said, we would always circle the first number, count on, and here we've done a big step. Now, as the children get older, we would expect them to make jumps in this way. However, at the very beginning, please get them to do those individual steps to help them, because they'll find it really tricky at the very beginning, unless they're quite competent in maths, to do that big jump. And then when they get to the answer, again, circle that answer to make sure. So I would like you now to have a look at this particular visual and the first, then, and now. And I would like you to write a number sentence to match this, and also use a number line, I'm sure you don't need to answer this question as well. So again, this isn't, please don't think this is to patronise, it's just so that you've got an idea of how to use the different strategies, so that when it comes to doing it with your children, you're competent with it as well. Okay, so hopefully for the first, you put 0 because there's nothing in the car. We can see that 2 children want to get in the car, so +2, and then the total is 2 altogether. If your child is really understanding it, move on to the commutative law, extend them by saying, is there another way that we could write this? And you might want to change the first and then and swap them over in terms of visuals. So if they're all separate, and you can make them separate, I would always encourage that, is have them as individual ones. Is swap over the first and the then and say, what does this look like now? What is your number sentence? And extend them and push them on to the commutative law. Like I said before, if they're finding this really tricky, move them back a stage to the aggregation and get them to count on individually using those apparatus to support with that as well. So you can support and challenge at each step. So we talked about the commutative law, and we talked about how we're telling our children and showing our children that we can present our addition and our multiplication in 2 different ways. So 4 + 5 is the same as 5 + 4, because we're just swapping them over. We're moving on to subtraction now. Please do, if you've got any questions, unfortunately my chat doesn't come up immediately, but if you do have any questions, please do shout out, because like I said, I know it's a lot of content today. So we're going to move on to subtraction. So like I've got here, I will put all of this information in the pack, but we talk about, we teach subtraction in lots of different ways, but at the very beginning, we look at partitioning, so taking things away and how many have we got left. We look at comparing, so how many more, how many less, how many greater. We look at and talk about the fact that subtraction is the inverse, so the opposite of addition. And we also look at reduction, which is counting back, just like we did in the aggregation stage of addition as well. So the first thing that we would do is the partitioning stage, which is looking at the amount of objects, people, whatever it might be, and say to the children, how many are there altogether? So we always break it down in steps. And that's really important as well. If your child finds it really difficult to complete multi-step tasks, whether that's verbal or in their work, then please break everything down for them. And we do that in their learning all the time. We would never just put a multi-step problem in front of them and expect them to work it out. We break everything down in steps first to support them. So how many people are all together? So they would count that. And for some children, they need to physically actually draw a line as they're counting to support them. So I'm showing you that here. And they would count as they do it, 6. Some children might not need to do that. As the children get more competent, they'll use their times tables to do that. So 2, 4, 6. Or they might just use their kind of visual understanding of maths and be able to just see 3 plus 3 is 6. But this is the very beginning of what we do. What we then do is introduce them to the number sentence. So the number sentence is 6 take away 2 equals. And again, when you're looking at the number sentence, don't expect them to know what it says and don't read it for them. And that's really important because when they're answering questions in class, when they're answering questions in their SATs and year 2 SATs or year 6 SATs, as adults, we cannot read the question to them. We cannot read symbols to them. So it's really important from the early years that you're encouraging children to read the number sentences themselves to make sure that they understand what that symbol is. And if you've got time, you can talk about the language associated with subtraction as well. So they will tell you 6 take away 2 is. So it's really important that you get them to do that and address those misconceptions. So again, what we're doing is we've got our 6 children there. And then what we get our children to do is take away the 2, so cross them out, and then to count how many they've got left. And they will tell you it's 4. We then move on to our first then and now in the same way as we did with our addition. And we would show them the visual. So first there were 4 children, 1 child got off. And then you can see the difference between the addition and the subtraction, because with the addition, you could see the backs of the children implying that they were about to get on. With subtraction, you see the front of the child or the person or the animal or the object, whoever it is, which implies that they've got off. And I know that sounds really obvious, but some of your children may not be able to understand that. So please unpick that with the children and say to them, is that child getting off or is that child wanting to get on? So again, 4 children on, 1 child gets off, how many are left? Can you write that as a number sentence? So again, in this box here, you would have these images, the first, then and now, already stuck in. They would be stuck in there. Then you would say to the children, can you write that as a number sentence? So I apologise because I've got addition here, but it would be subtraction, and they would write that in. So I've just changed that. So they would write in the 4, take away the 1 is the 3. But like I said, in this box here, you would have the visuals just as we've got here, and then they would write the number sentence to match. And we would talk about the commutative law and say to them, can we do 1 takeaway 4? Have that conversation with them and then stress that it's not the same as addition and multiplication. We don't have the commutative law for that. So I would like you to have a go at this. As usual, running out of time, so I'm going to speak quite quickly from now on. So if you have a look at this one, and I'm putting this here, it's quite confusing, but I'm putting this here because it's really important to address those misconceptions with children. Are they reading and looking at the visual representations really, really carefully? So always plan for those as well. And it's not to trick our children, definitely not, but it's just to make sure that they've mastered each of those different areas, because that's what we want them to do in any situation, to be able to apply these strategies. So hopefully you would have written 3 take away 0 equals 3. Because you've got 3 in the boat, no one has come off, and so you've still got 3. And again, they can use the number line to help them. The next step of subtraction is to understand that subtraction is the inverse, so the opposite of addition. And again, we've got here a part-whole model, and it is put at an angle, again, just so that children are really aware of which are the parts and which is the whole. So we know that the 3 and the circle with a question mark in is leading to the 7. So 7 is the total. So 3 add what makes 7. So the inverse of that would be the total, which is 7, take away the part. So 7 take away 3. And that's really important for you to kind of model to children. And we do that in so many different ways. So I've got another, a few examples here. We've got some numicon, and we've got the total is 10. We've got one of the parts is 9. So they would draw in here the missing numicon, and they would do that in an image in the same way visual representation as this is shown here. And the same here in the bar model, we've got 22 as the total. One of the parts is 4, so what is the other part? And you can do this in lots of different ways. If your child finds number lines very difficult, then again, go back to the aggregation stage where you've got counters, you've got numicon, you've got compare bears, counters, whatever it is. They've got 7 at the very beginning, their total, and they take away 3. If they've progressed from that and they can do that, move on to the number line. So just like we did with addition, find 7, circle it. This time we're taking away. So have that conversation with the children. Are we moving forwards or are we moving backwards? Yes, we're moving backwards because our number is getting smaller. How many steps are we moving backwards? We're moving backwards 3. So again, we do those individual steps. 1, 2, 3. What number have we landed on? 4. Well done. Circle that. So please use those different strategies with your children. If you've got children further up into 5 and 6, like I said, I will be sending the pack which will show the progression in each of these stages. So it will work up to the written methods for the children, where they will be borrowing, exchanging as well. So that's what it will be working up to. So you can see here, I've drawn the 1. So you always represent it. The children always have to write their answer as is being shown. So if a child wrote 1 here, it would not be accepted as a mark because they have not followed the visual representation that has been shown. Same here, if they drew 4 cubes, it would not be accepted as an answer. We ourselves would accept it as an answer, but we always say to our children, please write it as shown. We know we have to write this as a number. We know we have to draw this. We know this has to be written as a number as well. So 22, take away 4 is 18. And we always say it back to the children. That's really important that we're always saying the number sentence to the children. The next stage is comparison, so comparing. And I'm showing you lots of different examples here because at home, please do that as well. And please make it as practical as possible. And the same goes all the way up to year 6. You will see our year 6s using the same strategies as the children lower down the school. Please do not think that when they're in year 6, year 5, that they cannot use any apparatus or anything to support them. They can. Unfortunately, they will not be able to do that in their exams. However, by doing that over the years, they will be able to build up a visual representation in their head. So when they get to that point, they will be able to work out the problem solving and reasoning with more fluency and adopt that visual representation in their head. So here we have got 7 and we've got 2. And what we do is we compare. Okay, so we compare in lots of different ways. We can say use the symbols greater than, less than, and equal to. We can then count how many more, how many greater, what is greater, what is fewer, and we use that language with the children. So we could say 7 is more than 2, is greater than 2. How many more is it greater? And then we take 2 off the 7. How many more have we got? And again here, we've got 9 take away 3. And so we've covered the 3 squares. How many have we got left? We've got 9 take away 6. And we've used just bits of paper, so really easy. Covered the 6. How many have we got left? So it's really easy to use lots of things at home to support with this. Like I said, I'm showing you the apparatus that we use at school, but you please use lots of different ways that and lots of different resources you've got at home as well. And we do it in lots of different ways in terms of using visual representation. So there are 5 minis and we've got 2 motorbikes. What is the difference between them? The difference is 3, and they would count on from there. And as you can see, it's all lined up to help them with that. And that's really important as well. And we talk about that because when they come up to doing the written methods, we talk about the place value of numbers and how they need to be lined up in order to help with the calculations. So it's really important from the very beginning to talk to them about that. This is a problem-solving question. So Ben is 10 years old, Charlotte is 3 years old. How many years older is Ben? And as you can see here, a bar model has been created to support with this answer. So we know the total is 10 because that's what we're working with, and we're comparing against Ben. So 10 years old, so 10 is in there. Charlotte is a part of that, so it's 3 years old. So what is the difference? So 10 take away 3 is 7. So again, I've just put that there to help to demonstrate that even when we're doing the problem solving and reasoning, we're using those strategies. We then talk about reduction. So I'm not going to emphasize this too much because we've talked about this. So again, counting back. So if we've got 5, we're counting back 2. So 1, 2. Now we've got it at the bottom there, but we don't do it at the bottom. We always do it at the top. But this is just showing you the +2 and the -2 and the relationship between them. But we would always circle the number 5 and go 1, 2, and then circle the 3. If we have the 3 and we're counting on, circle the 3, 1, 2, and then circle. Now, if your child is starting to add on past 10 and they're bridging the 10, which is what we talk about, what we say to the child is, how many steps is there from your number to the next 10? And they do that jump first. And that's really important because it's showing you their number bond knowledge to 10. And they do that first step first. Once they've got to a 10, then what they do is then do their individual steps after that. So for example, if I said 3 plus 8, we know that goes beyond the 10. So what we say is, how many to the 10? So that's 7. And how many more? It's a 1. So they're doing it that way. They always go to the 10 and then move on. So that's how you bridge through the 10. We're going to move on to multiplication, and I definitely am going to speak very quickly because 15 minutes away. So these are the first kind of layers, and obviously it gets I'll talk about the different stages after that in terms of year 5 and 6. So we look at multiplication as repeated addition. We look at scaling of numbers as well, so whether that's doubling, trebling. When they get older into year 5 and 6, we talk a lot about ratios and scaling and the scale factor as well. And we also talk about the commutative law in the same way as we did with addition. So A times B is the same as B times A. So again, we look at repeated addition at the very beginning. So I know that 2 plus 2 plus 2 is the same as 3 lots of 2. And we say 3 lots of 2 because there's 3 groups with 2 in it. I know 4 plus 4 is the same as 2 lots of 4. And as you can see, I'm using that different language for multiplication. Instead of saying 2 times 4, I'm saying 2 lots of. So please try and think about how you use your language for the 4 operations in lots of different ways. Don't always use addition, subtraction, multiplication, and division. Talk about total, talk about the differences, talk about lots of, talk about sharing. Again, 3 plus 3 is the same as 2 lots of 3. And then we've got these visual representations here, and then we've got these models here as well to support with the multiplication. And I'm just going to show you some examples now of that. So this is the language that we use. How many groups are there? How many are there in each group? And how many are there all together? So for example, there are 3 groups, 2 in each group, so 3 times 2. How many are there all together? 2, 4, 6. So that's the language that we would use. And we also use something called arrays to match the number sentence as well. That's really important. And we can either do this physically. So if a child finds writing quite difficult, or we can see that that's slowing them down, we would get physical counters to help, or cubes, whatever it may be, to support with showing this. And we show it in lots of different ways as well. So we've got our 2 rows of 3, or we've got 3 rows of 2, and that's really important to show them the different ways that that can be represented. Again, once they've got their fluency and they know how to represent those arrays and they know how to read them, we give them those problem-solving questions. So who has represented this picture correctly? So I'll just give you a couple of seconds to work out the answer. Is it Sally, Ahmed, or Kumiko? And it can be more than one person. And the children will be correct in saying that it is Sally and Ahmed. 3 lots of 4 and 4 lots of 3. As the children get older, they will learn about scaling, and we do that in lots of different ways. So lower down the school, we would say, can you build a tower which is twice as high as this one? So thinking about how many have I got now? I've got 4. If it's twice as high, that's 4 times 2. How many do I need? I need 8. So again, we don't just expect them to go straight to the answer. We get them to look at the visual, write it as a number sentence, and then we get them to actually show their representation. I've just got someone coming in. As they get older, we then look at recipes and get them to scale it up. So we would put at the bottom, this is a recipe, for example, for 4. I want a recipe for 8 people. So how many scoops of vanilla ice cream will I have for 8? So again, they're scaling it up, and that will progress as they get further up in the school and more competent with maths as well. Again, looking at problem solving like this, I'm 3 times as tall as you, I'm 3 meters tall, I am only 1 meters tall. So using that information to create their number sentence as well. And we also use lots of apparatus like Cuisenaire to help with that scaling and that visual representation. So this is an example. So it says we're going to make 5 lots of this recipe. Can you write down how much we need of the following ingredients? So this is 1 lot, and we need 5. So we would expect the children to multiply this by 5 to find out how much that would be. And as you can see, I've put a challenge there in terms of water and the strong flour as well. I'm just going to move on. We also then talk about the commutative law, so knowing in the same way as addition that 5 times 2 is the same as saying 2 times 5, and showing that in different ways as well, like we've shown the representation there compared to there. So you can use lots of different resources to support with that. I'll just show you this as well. And you can play around with that and say to them, how many different ways can you show 7 lots of 2? And play around with that in terms of the representations of that. I'll just move on because this is something for you to do, but hopefully you will get it that, you know, we can represent that as 5 times 3 or 3 times 5. So we'll move on to division now, because we then need to move on to how to support children and different ideas as well. So for division, we have equal sharing. We have that it is the inverse or the opposite of multiplication. And we also have a look at ratio structures, which we looked at the inverse of that with the scaling for multiplication. So equal sharing. Again, we have a really systematic approach to how we break this down for children in the same way as multiplication. How many groups are there? How many are there in each group? How many are there all together? The same type of language is used for division as well. So here we have got some problem solving. So it says, are these objects divided equally or unequally? So at the very beginning of division, at the very beginning, you may see that your children have a look at symmetrical objects. So they may have a look at butterflies and put stickers on each side and share the stickers between each side. It may be that they look at a ladybird and they look at dividing stickers between each as well. So making it really practical. Once they've got that really good understanding of sharing amounts between 2 parts, then they move on to understanding equal sharing, which is the point we're at now. So we would say to the children, are the objects divided equally or unequally, and how do you know? And like I always say, if you're new to these sessions, throughout the school we have our key questions in black, and we have our sentence starters in blue, and we have this up for every single lesson. Even those children that are very competent and very confident in talking, we still have the keywords up on the board to support them with that, and they don't need to use these sentence starters, but they're there to support. So the objects are divided equally, unequally, and I know this because I'm always proving it, like we talked about in the reasoning. So we can see clearly that these objects have not been divided equally, because I've got 2 in the first group, 3 in the second, and 2 in the third. So I know that it's not divided equally because the second group has got more cars than the first and the third group. So you'd have a little conversation about that. And again, have the same question again. Is it divided equally or unequally? Yes, it's divided equally because I know that there are 4 equal groups which have 3 in it. This is a little activity for you to do, but I will quickly just show it now because we're running out of time. So I was going to get you to divide the cubes into 5 equal groups. So you would have worked out that there were 10 altogether, and there's 5 equal groups of 2, and then you would get the children to extend that by writing down the number sentence as well. We also look at division being the inverse of multiplication. So again, using the language, the total numbers of bears are, so we can see that that's really important with division, just like subtraction. Think about the total first. So we have got 2, 4, 6, 8 bears altogether. That's a total number of bears. How many bears are there on a plate? There's 2. So 8 divided by 2 is 4. And it's really important to keep talking about that and writing that down. And then we've got a visual representation on the board. So I was going to get you to work out the total number of cakes, how many groups there are, and how many cakes there are in each group. So you would have worked out that there is 15 divided by 5 is 3. And again, once they're really confident in understanding equal sharing and the inverse of multiplication, they will then look at problem solving and reasoning. So which of these sentences correctly describes the picture? There are 6 equal groups, or there are 3 equal groups. So how many equal groups are there? Yes, there are 6 equal groups. How many are there in each group? So again, extending them, even though that's not there, keep extending them. There are 3. Can we write that as a number sentence? Again, that's not there, but you're extending and challenging your child. And then we're looking at ratio structures, so scaling things down, and also thinking about scaling down recipes. So for multiplication, we multiplied, and for ratio within division, we will divide and scale it down. So for example, here it says we're going to halve this recipe. Again, we're using that language. What does half mean? What does it mean with regards to division? Okay, it means divide by 2. So we're going to halve it. So milk was 250, half of that is 175. There was 2 scoops of vanilla, half of that is 1. And there was a cup of strawberries, half of that is half. I'll get to this point at the end because I want to talk about what kind of strategies you're going to learn and any further questions. But because of time, I'm just going to move on to this supporting children with those additional needs, and then we can kind of have questions at the end. So that was kind of a general kind of overview of the 4 operations, the 3 stages. Like I said, I would be here all day if I went through each individual year group. So I will be sending that document, and you will be able to see the progression in addition, multiplication, division, and subtraction from year 1 all the way up to year 6. If your child is in early years, I will also attach the new Eyfs Curriculum, which is called Development Matters, which will have mathematics in there and also the areas that they're learning in. It used to be divided into months, but now it's divided into 3 categories. It starts with birth to 3, 3 to 4, and then reception ready. So have a look and see in the maths curriculum where you think your child is, and talk to your teacher as well about what targets your child is working on. Hopefully, during your parents' evening this week, you will have had that discussion with them to see where they're at. If you didn't get time to talk about that, please do email your teachers at your year group address, and they'll be able to give you the target that your child is working on. So just like I said kind of at the very beginning, for those children that have additional needs, or they're very new to English, and also may need support in other ways, we're always using that concrete and pictorial representation with them. We never take that away, and that's used all the way through from fluency, problem solving, and to reasoning as well. And please do the same at home as well. We also, as a school, always revisit prior learning, and the White Rose Maths unit plans are always great at showing that. And it always provides opportunities to revisit the prior learning and address those misconceptions as well. And we always plan for those misconceptions. And if we have found in the learning the day before the children were finding X, Y, and Z tricky, then we always amend our planning to put that as a starter to talk about it, so that we've addressed that ready for the next session. That's really important. And I've just put a quote here from the Education Endowment Foundation, which is a really great foundation which supports teachers in education. And talking about misconceptions, it says an understanding that leads to a systematic pattern of errors. Often misconceptions are formed when knowledge has been applied outside of the context in which it is useful. So it's really important for us to address those misconceptions, because if a child is carrying on with that false knowledge, then that obviously impedes in other areas of learning as well. So we do plan for that, and we do that in lots of different ways, through classroom discussions, through peer work, group work as well. And they're able, through doing that, children can then restructure their answers, but it also makes them become resilient learners, because they're working from the mistakes that they've made. And we always celebrate errors in our learning, whether it be maths or any other areas. We always learn from that. I talked a little bit about this before, which is pre-teaching. So there are some children that find maths very, very difficult, especially the language and the content as well. And as a result of that, what we do is, for some of those children, is on a Friday, they will sit down with their teaching assistant or their teacher, and they will look at the key words that they're learning the following week. And I've just put an example of what that might look like. So this is this program that we use, I purchased last year when I first joined, called Widget, and it has the visuals which go with the words as well, which is really important. So what the adult does is they say, next week we are going to be learning, and these are our key words. So they read the words with the child, they talk about what those words might mean, and then this document then goes home with the child. So if you ever get this document home, hopefully you would have had that conversation with the teacher about your child finding maths very tricky, and before receiving this, is then at home, if you do the same thing, talk about the words, think about different meanings of that word as well, how that can be represented, so that when they come to their learning the following week, they've got that confidence and it's not all new and overwhelming for them. There are also knowledge organisers as well. So for some children as well as the key vocab, we also give them a knowledge organiser, which is 2 to 3 pages of information about the new unit that they're learning. So I've just given you an example there of one which is on number and place value, the first sheet of it. That would come home with the child. It'd also be spoken about with the child as well. We are learning about number and place value this week. This is what we're going to next week, this is what we're going to be learning, and then that will come home. And if you could do the same as well. If your child does not get key vocab or does not get a maths knowledge organiser, and you do think that that would be helpful for them because they find maths very tricky, again, please do email your class teacher through info or the year group email, and they'll be able to put that in place for you as well. For yourself, if you do want to find these knowledge organisers, if you've got a Twinkle account, they are all on Twinkle, so you can get them from there as well. And what we always make sure we do at school is make it as fun and as cross-curricular as possible. So I've kind of shown you an example here. So we link it with books, we link it with lots of topics that we're doing within the curriculum as well. So this book that I've kind of given you an example of is called Each Orange Had 8 Slices, which is a counting book, but it also helps with fractions, understanding multiplication and division as well. So again, try and make it as fun as possible. And there are lots of amazing books and resources on a website called MathShed. And MathShed is amazing because it has lots of videos, it has lots of recommended books as well. So if your child is a really visual learner and really practical learner, this is a really great resource to use to support your child at home. There are also parent carer workbooks for the White Rose. So if you type into your search engine White Rose parent workbooks, you will be led straight into a website. I will put it in the information as well. And it will give you the year group, it will give you your term, autumn, spring, summer, and you will be able to see all of the units for your child for that particular year. So if you found when you spoke to your child and through home learning that your child found it really difficult doing shape, for example, you can then find the workbook on the website, and it will have lots of different questions all the way from fluency to problem solving to help consolidate that. So please do use those parent workbooks. They are free for you to use. If you need us to print them out, please do contact us at school and we can print it out and put it in the child's bag for you as well. And that will help consolidate those misconceptions that the child has got. You can also do that the week before as well. So if you see in the next week's learning that they're doing shape and you want to do this before next week's learning, then you can also ask us to do that. We put it in their bag and then they're ready for the next week and they've got that confidence for the next week. So I've put the website there, but I will put it in the email as well. The White Rose also has video instructions, which you will have used in the first and the second lockdown. And that's really important because it helps embed the teaching. I please want to stress here that during our maths lessons, we don't play this and sit back and that's the learning. The teacher has their own presentation and uses their slides as well as some of the White Rose slides in order to teach. But White Rose do have additional videos. So if we have children that have found it super tricky, a concept very tricky, then in the afternoon, what happens is the TA will take them out and they will use these videos and they will use extra resources and extra questions to consolidate and also address those misconceptions as well. So we're always using the supplementary material to help us. And one of the questions that we got in the chat was, how can I make it practical? How can I make sure that my child doesn't find maths boring? We are very much like that as a school. So please bring maths to life. Please make it as enjoyable as possible. So use the outdoors to bring maths investigations to life. So it seems very bonkers, this picture, but this is an example of us finding out and estimating and finding the height of a tree. I did this with my year 6 pupils. We went outside and this is legitimately how you find out the height of a tree. So walking backwards, bending until you see the top of the tree and then measuring the distance. And we also look at the age of the tree as well by measuring the circumference. So again, lots of different ways, counting objects as we go around, doing a nature walk, all those things, like I said about using chalk outside to do number lines, hopscotches. You can do a hopscotch with times tables. It doesn't need to be in consecutive numbers. Whatever times table you're learning that week, do it with that times table. Whatever you can do, please do and make it as practical as possible. And also watching clips from TV programs, which I know sounds doesn't sound that inspiring, but actually children learn so much from programs like Number Blocks, and they have really good episodes. So one particular episode called The Wrong Number, where the secret agents have to find out missing numbers from the clues that they've got. So again, you can pause that, and you can do your own investigation, become your own detectives. You've got clues around the house. You come back to watch the programme and find out if your answers match theirs. So please make it as practical as possible, because they absolutely enjoy it when you do that. Super obvious, because I'm sure you may have done this when you were at school, but also using role play, doing shops, making shops. Also, when it comes to a particular festival, Easter, making recipes, so thinking about ratio, thinking about scaling, thinking about measuring as well. So using all those skills help get your children, I know sometimes it can be more of a hindrance than help, but getting your children to help with cooking, with baking, because they're going to use all of those skills. Barclays and John Lewis also have really great resources to help those older years, so year 4, 5 and 6, and they talk a lot about enterprising and kind of profit loss and all of those kind of key skills to help them for their future. So please have a look at those websites as well. And we've talked a little bit about this, the links between literacy and maths, finding really great maths books that will help with their understanding of maths. Like I said, if you have a look on the website Maths Shed, it will have lots of different books there. It also has them as a visual, so it's already, someone is already reading it. So that's got the auditory and the visual element to it as well. So it's already done the work for you, which is great. The Doorbell Rang is a great book about sharing. Again, you can act this out. You it's about cookies as well. You can make the cookies, share them, so lots of different practical ways that you can bring it to life. This is really fitting, especially because I've talked to you for a long time now, is cognitive overload. So for some of our pupils, the maths curriculum and other areas of learning is quite overwhelming. There's a lot of input, there's a lot of language, there's a lot of knowledge, there's a lot of skills for them to acquire, and they do find that very difficult. So we do, for those children that find it very difficult with focus, concentration, process and retention, we do make sure that they have a break, and we're very aware of who those children are. And we do lots of different things with them. We have sensory circuits, they may have fidget toys in class, deep breathing, even hydrating themselves, really important. Even just getting up and walking to the sink and getting their water bottle, that movement in itself is important. At school, we have lots of things like trampolines, we have balls, we have movement boards, we have therabands on chairs. So lots of different things that we do with the children to support them when they're finding it really overwhelming, when they need that short amount, when they need that short break, and when they need to go back. And the reason I've put this here is please kind of think about this at home as well, when they're doing their home learning. Can you see the signs where they're finding it very difficult? The behaviour is about to start, they're either acting in or acting out. And at that point, or even before that, just stop, do one of these things with them, and you will know yourself what works best for your child. If you don't, and you're still exploring that, and they're still creating their own toolkit, then do a range of them, and then the child will build up their own toolkit over time. And that's something we're talking about in the last session of before half time, which is about strategies to support children with their mental health and well-being and with cognitive workload. So these are just some of the ideas there. Last 2 slides, I promise. We have got timetable rock stars at school, and at school we do this either electronically or we do it on in paper form. When it's done electronically, there is a 3-minute timer, but we are very aware that that is very overwhelming. For some children, it provokes anxiety, and so for that reason we get them to do it on paper in their own time. And each child has a timetable rockstar username and password, and it should be stuck on the inside of their reading record. If it isn't, please do contact your teacher at the address above that you can see. So you put year and whatever year group your child is in. teacher@grovens.surrey.sch.uk, and they'll be able to tell you what it is. And the last thing that we are introducing for the younger children this year is something called numbots. So this is where they will practice those numeracy skills, those basic numeracy skills to support in other areas of learning at the beginning of their education. So they'll be able to do this at school either as an intervention or at home as well. And Mrs. Kendall, the maths leader, is currently setting this up, so there'll be more information to follow about that. And again, your child if they're in the younger years, will get a username and a password for this stuck in their reading record. So that was a lot of information. I appreciate if your child, if you wanted to know specific things about a particular year group, you may not have heard that today, but hopefully you will have seen what the 3 stages are, the different ways that we teach it and that you can do it at home. And like I said, that document will kind of talk through the progression for each of those 4 operations from year 1 to 6. Were there any questions? Now, I will, if there's any personal questions, I will do them at the end, but if there's any general questions, I'm just going to leave the recording on for the moment because this might apply for some other parents as well. You can either put it in the chat or say it out loud and unmute yourself. Okay, I think that's no questions. So I will, hopefully it's recording.